In this video, I'm going to explain why we use or why we transform expressions like this in these forms. So we went through this process. So I went through an example, and I call this example number 2 in the previous video, and I showed you the steps. Okay, the steps specifically in order to find R and alpha. Now I'm going to continue on further, so I want to show you how to find the maximum and minimum values of 5 cos x minus 15 sin x, or expressions of this type. And I'm also going to show you how to work out firstly the range of y equals 5 cos x minus 4 sin x, so for examples of this type, and using a range finding the maximum and minimum values of expressions like y equals 5 cos x minus 4 sin x. Okay, so just to continue with this example, so 5 cos x minus 4 sin x, we wrote that as root 41 cos x plus 38.7 degrees. So let me show you how to find the range. So to find the range, so let me take a red pen. So we wrote this in terms of cos. Okay, so we wrote this as root 41 cos x plus 38.7 degrees. So in step number 1, when we work out the range, first write down the range of cos x. Okay, so the range of y equals cos x, so cos x lies between 1 and minus 1, so that arises when you sketch y equals cos x. Okay, so if you graph y equals cos x, or even if you graph y equals sin x, they both have the same range. So cos x and sin x both lie between minus 1 and plus 1. Okay, so this is also applies to sin x. Sin x also lies between minus 1 and plus 1. Okay, graphically. So in step number 2, give the range of cos, or y equals cos x plus 38.7 degrees. So the range of y equals cos x plus 38.7 degrees. So the range of that also lies between 1 and minus 1. Okay, because this is basically a horizontal shift. Okay, so it's a horizontal shift, so it wouldn't alter the 1 and minus 1. Okay, the maximum and minimum values of cos. Okay, and finally in step number 3, to find the range of root 41 cos x plus 38.7, okay, all you need to do is multiply throughout here by root 41. Okay, so range y equals root 41 cos x plus 38.7. So if we multiply throughout by this term, root 41, so if you multiply this inequality by root 41 throughout, so let me just make a note, multiplying by root 41, that inequality in step number 2 throughout, you're going to get minus root 41, and that is root 41 cos x plus 38.7, and root 41 times 1 is root 41. Okay, so those are the steps in order to find the range. Okay, and if you wanted the maximum and minimum values from this, the plus root 41, so the value on the right hand side will be your maximum value, the minus root 41, that would be your minimum value. So this value here is your maximum value, and this value here is your minimum value. Okay, so here are the steps in order to work out the range. So this also applies when you have an expression that is transformed into a sign. Okay, so remember, bearing in mind that sign has the same range when you start off with step number 1, the steps further to that will be exactly the same. Okay, so that is how you'd find the range and the maximum and minimum values. But I want to continue on further and show you how to find the smallest positive value of x in this case, that gives you the maximum value, and as well as the smallest positive value of x that gives you the minimum value. Okay, so let me continue from here and let me show you how to find the smallest positive x that gives you the maximum value. So I think a fresh sheet of paper is in order. So in order to find the smallest positive x given the maximum value, so let me just go backwards slightly. So what I usually do is I equate this centre expression here in the inequality to the maximum value, and then we solve that equation. So to find the smallest positive x given the maximum value, remember, equate that centre expression in your inequality to the maximum value and solve that equation. So, and also note that we're finding the smallest positive value of x. Okay, so here goes. So let's equate that centre expression. So it's root 41 cos x plus 38.7 to the maximum value, which is root 41. Okay, so remember, this is the smallest, so we're working out rather the smallest positive x given the maximum value. Okay, so I hope you can see that. Okay, so further to that, so in the next step, I'm going to divide both sides by root 41. So if I divide by root 41, we're solving cos x plus 38.7, that's equal to plus 1 on the right. So in one of the videos on trigonometry that I did, in order to solve an equation like this, so if your angle is not x on its own or theta on its own, use the substitution. So I tend to use t, so I let t equal that angle. Okay, and so if I let t equal x plus 38.7, we're going to be solving cos t is equal to 1. Okay, so the one on the right hand side is positive, and if I calculate the principal value, so inverse cos of 1, that's a standard result, that's 0. Cos 0 gives us 1. Okay, so let me draw the cast diagram here. Let's include some quadrants. So all sine, tan and cos. So we're going to plot 0 where cos is positive. So cos is positive in the first and fourth quadrants. So 0 degrees from the horizontal in the first quadrant is here, and 0 degrees from the horizontal in the fourth quadrant also here. So solutions for t are, okay, so let's find the t solutions first. I'll call the first one t1. So t1, so from the initial line, so where we plotted the angle, that lies exactly on that initial line. So the first solution is 0 degrees. Now, if you think about it, these are the solutions for t, and when we find the solutions for x, x will be t minus 38.7. Okay, so if you think about it, if we calculate the x solution, so mentally speaking, x will be t, our first solution for t is 0, minus 38.7, so that's going to be a negative angle. Okay, however, remember, we want the smallest positive x. Okay, so the smallest positive x, that's what we're after. So it's wise to calculate another solution for t. So let's work out another one. T2 will be, so if I take my red pen, so from here, from the initial line, one complete revolution, and one complete revolution is 360 degrees. Okay, so that's going to be the second solution, so I hope you can see that. So we're looking for the smallest positive value of x, so let's go to our substitution to work out what x is. So let's continue. So since t is x plus 38.7, the first solution for t, as we discussed, is not going to work. So let me just put a cross there. So let's look at the second solution for t. So when t is 360 degrees, okay, so firstly, when I rearrange this, x is going to be t minus 38.7. So in this case, rt, we're using 360 minus 38.7. So let's have a look. So we're going to get roughly 321, so 321.3 degrees, I believe. So I hope you can see that. Okay. So, and that indeed is smallest positive x giving the maximum value in this case. Okay. So this also works if you want to find the smallest positive x given the minimum value. The steps are identical, but the only difference is you're going to be replacing. So if I go back to the previous page, you're going to be replacing. So you're going to equate the center expression in your inequality to the minimum value, and solving that equation to find the smallest positive x. Okay, so previously we found the smallest positive x given a maximum value, so we equated the center expression to the maximum value and solved. But to find the smallest positive x given a minimum value, equate that center expression to minus root 41, use exactly the same steps to find the smallest positive x giving the minimum value. Okay, so that completes the video. I hope you found that video helpful. Do related problems, and I hope to see you again in the next